Hello everyone and welcome to our first section. We'll build up on the techniques we learned so far in the first course and add more analysis tricks to our arsenal. The course will ramp up quickly, so if you have any questions, please post them in the Q&A section for all the students to see and benefit from. Each lecture will explain a concept or an analysis step, and we will follow up with a screencast to see it in action. Make sure to practice on your own after watching the videos. The samples and all the scripts discussed during the lectures are provided in the resources sections. Before we begin, let's discuss the benefits of virtualization versus using physical infrastructure for behavioral analysis of unknown samples. We can simulate multiple machines on a single physical machine, all interconnected, and observe the traffic between them. For example, we can have our malware sample executing on a Windows machine, while another Linux virtual machine would run necessary network infrastructure, like a web server, a DNS server, an FTP server, and so on. Using virtual machines greatly speeds up the analysis process, since we can have VMs already configured with all the necessary software and our tools ready to go. Another important benefit of virtualization is that we can programmatically spawn virtual machines when needed, execute samples, and collect execution artifacts. There are great projects like Cuckoo Sandbox exactly for this purpose. This way, we can create a complete malware analysis pipeline, going through dynamic execution and ending with the extraction of any indicators of compromise found. A lot of malware samples will only execute on specific environments. For example, exploits will only work for certain vulnerable software versions. Virtual machines allow us to have multiple configurations available and spawn each one when needed. We can virtualize an entire network without additional hardware, greatly reducing the costs of equipment and maintenance. Another very important feature of most virtualization software is the ability to take snapshots. We can do this before an infection, so we can go back to a clean state anytime, but also during long investigations when we reach certain critical points. You really need to go through a long exploit debugging session to appreciate the benefits of snapshots. Now that we understand the benefits, let's see what to do to stay safe. Although there are numerous advantages of using virtual machines, there are still a few points to keep in mind to make sure our production systems stay safe. We have to consider that there have been several publicly announced vulnerabilities in VMware that could allow malicious code from the virtual system to find its way into the physical host. They have even been demonstrated publicly at security conferences, although no source code is readily available online, and luckily these techniques have not yet been incorporated by malware authors. In this course, we'll focus on VMware, which offers both a free version and also a 30-day trial of their VMware workstation, which has all the features available. The techniques discussed here apply with slight differences to other virtualization software also. Tips to stay safe. Install all the security patches available from VMware. To be extra cautious, use a dedicated physical host for the VMware-based lab. Don't use it for other purposes. Do not connect this host to the production network or directly to the internet. If doing threat intelligence activities, use a dedicated, unattributed network to reach the internet. Configure the VM to be as stealthy as possible and test it with virtualization detection tools. More on this topic later. Next, we'll go through the installation and basic configuration of VMware. As we mentioned, we'll focus in this course on VMware. Other good alternatives are VirtualBox and Hyper-V, both free. VMware Workstation offers a free version, but this one lacks the snapshots feature, which is essential for our analysis. For the purpose of this course, we can use the 30-day trial version. We will not insist too much on the setup itself, which is pretty straightforward. Just a quick note, if you're using macOS, you will need to download the VMware Fusion. VMware tools offer better integration with the host operating system, drag and drop files, shared folders, seamless resizing of the VM window. If using this, keep in mind that it is very easy for malware running inside the VM to detect that it's actually virtualized by the presence of VMware tools binary in the running processes. Another aspect to be aware of if you're using VMware tools is that all the data in the shared folders is readily available for malware processes as it would be a local folder. Data from the shared folders can be accessed, exfiltrated, or even encrypted if you're analyzing ransomware. Be careful. To achieve network isolation, if you're using only one virtual machine, the best option is to set the networking to host-only mode. If you're using multiple virtual machines to simulate a small lab, VMware offers the possibility to create a separate virtual network. We will not cover this option here, but link external resources to get you started if you decide to build your own VM lab. Lastly, one of the useful features for malware analysis is the ability to take snapshots. We can do this while the machine is powered off, but also while running. Capturing the state of a running VM is hugely useful and allows us to progress through lengthy debugging sessions. We will see how this works in action in the next video. Now that we have discussed the main configuration steps, let's go on and prepare the operating system for malware analysis. Since we'll be discussing Windows malware analysis, we first need a Windows OS image. To make sure we're not infringing any copyright laws, we will download a free Windows virtual machine made available by Microsoft to test Internet Explorer 11 and Microsoft Edge browsers. Because these virtual machines expire after 90 days, Microsoft recommends creating a snapshot after the first installation so that we can roll back to it later. Next, we will install our analysis software. Tools for static analysis like XCinfo, IDA Pro, PEView, CFF Explorer, PEstudio, UPX Unpacker. Then, tools for dynamic analysis like Regshot, Sandboxy, Process Explorer, Process Monitor, debuggers, and others. Tools to investigate network traffic, for example, Wireshark, Barb Suite, Fiddler, network miner, A-PAIT DNS, capture BAT. We also need different software versions, especially if we're doing exploit analysis. Some malicious payloads only work for certain versions of Internet Explorer, Microsoft Office, Adobe Reader, Flash, and so on. We need to have this in mind. Just because a sample doesn't do anything in a specific VM configuration doesn't mean it doesn't do anything at all. If possible, install the software from a local repository rather than connecting the virtual machine to internet to download them to reduce the infection probability. It's also best to disable any endpoint protection software or antivirus from the VM because it might silently delete or clean your samples or may hinder the analysis. After setting everything up, remember to take a snapshot of your clean machine. To recap, in this lecture we've done the following. Discover the benefits of virtualization software. Learn tips to keep the production system safe when using virtual machines. VM installation and basic configuration in preparation for malware analysis. Prepare the operating system, analysis tools, and took snapshots. In the next lecture, we'll harden the VM and discuss virtualization detection. And to conclude, please take time to study these reference resources since they provide additional context to the techniques explained so far. Thank you and see you in our next lecture.